Okay, let's give you guys some more practice. So work out the limit of tan of x to the power of cos of x as x tends to pi over 2 from the negative direction. So press pause and have a go. Okay, so we are trying to find the limit of this. So we are trying to find the limit of this. Let's just say the whole limit is the number y. Let's just say the whole limit here is the number y. So we are trying to seek this number here. We are trying to seek y. So from here, natural log equally to both sides. So that will then give you this. Remember, when you natural log of this, the cos can go down here. So you can carry the cos here. And then you've got your natural log here, natural log. And then you've got your tan here. So once you're here, let's check it now. Once you're here, once you're here, you've got one block multiplying another block. So let's try and check this. Where will this head towards? Well, if you look at the natural log, if you look at the cos graph, as x tends to pi over 2, so this is pi over 2 here. As x tends to pi over 2, you are heading towards 0. So this block here will head towards 0. Now, as you're heading towards pi over 2, well, let's look at this here. The tan graph looks like this. Tan graph looks like this. This here is pi over 2. So as you're heading towards, as x is heading towards pi over 2 from the negative direction, so that means from the negative direction, you're heading to pi over 2 from the negative direction. This is going to head towards positive infinity. So this thing here will head towards positive infinity. But then you're natural logging something that's heading towards positive infinity. Well, if you look at the natural log here, as you're heading towards positive infinity, this thing here is going to head towards also towards infinity. So if you think about it, this is heading towards 0. Tan of x, as x tends towards pi over 2, it's going to head towards infinity. And then here you've got natural log of this thing here. So natural log graph will look like this. So the natural log will actually also head towards infinity. So here you've got 0 heading towards 0. Here you've got infinity, and you've got the product of, well, this is a product. So whenever you have a product, you can always rewrite it as a fraction. So this is an indeterminate form, and it's a product, so you can always rewrite it as a fraction. So imagine this. Well, rewrite this thing here as this. Okay, so now imagine this thing here as a secant of x. So now let's just check this. So let's check it. So if you put this into here, this is going to head towards positive infinity, and then if you look at the natural log, this is also head. Well, this whole thing here will head towards infinity. This bit here will head towards infinity, and then well, secant of x. Let's just look at this one. These two are the same. As if you look at cos, it will look like this. So this is pi over 2 is here. So as x tends towards pi over 2, cos will be 0. And then you've got 1 divided by 0 here. This thing is going to head towards infinity. So here you've got infinity over infinity. So it's an indeterminate form. That means you can use L'Hopital's rule and differentiate it. So hang on. So because it's infinity over infinity, we can just differentiate this. That will then give us this. And then differentiate this. That will then give us this. So now this thing gets multiplied to the top. So that will then give you this. So hang on. We are here at the moment. This thing here gets multiplied to the top. So this whole thing here will become this. And then you've got your divide here. That's this divide. And then this thing here is this thing here. And then here you're dividing a fraction, so it gets multiplied to the bottom. So this one here will then become this. Well, think about it. This thing here, this thing here gets multiplied to the bottom. So the secant gets cancelled out here, giving you this. And then the tan, with the tan here, that will give you tan squared. Okay, so now visualize this. Visualize secant as 1 over cos divided by tan. Remember, tan is sine theta over cos theta. Here you've got squared, so it's squared. So now tidy this thing up. So you well, this times this, that will then this times this, that will then give you this, and then tidy this up. Tidy up, it will then give you cancels out. That will then give you this and this, and then if you look at this, cos looks like this. This is as x tends to pi over 2, cos will head towards 0. And then if you look at sine looks like this. This is pi over 2 here. So as x tends to pi over 2 from the left hand side, sine will head towards 1, but then you've got squared here. So here you've got, here this thing is going to head towards 0. Here this thing is going to head towards 1 squared, which is 1 here. So nothing breaks down here. So 0 over 1 is legitimate. It would be problematic if you have 1 over 0. But here you've got 0 over 1. Nothing breaks down. So it is a legitimate answer. So this thing here will be 0. So this whole thing here will be 0. And remember, right from the start, we took the natural log of both sides. If you scroll all the way back up there, what's on the left hand side is actually natural log of y. So it is the y that we're after. We are after the limit y, but then we took the natural log of y. If you scroll back, well, you can't scroll back, but if you go back to the beginning of the video, we took the natural log of y. Well, blah blah blah. So here we've got natural log of y equals 0. So now we are after the number y here. It is y that we're seeking. So from here, exponentiate equally to both sides. That will then e equally to both sides. That will then give you this. And then now these two, in a way, this whole thing here will become y. So this thing here is this. Well, e to the power 0 is 1. So your overall limit will be 1. Now, if you get a graph plotter and plot it as x tends towards 0. As x tends towards. If you get a graph plotter and plot tan x to the power of cos x, as x tends towards pi over 2 from the left hand side, you can see that it is approaching 1. That's why our limit here is 1. Yeah, okay.